In this video I want to discuss how to select various parts of a Pandas data frame. So here we've got an example of a data frame. It's kind of like a spreadsheet or something. So we've got all this data in the middle, and it's all about planets. We've got an index column here. The index is just the names of the planets. And then you've got separate columns over here for the mass, the diameter, distance from the sun, the orbital period, the average temperature, and the composition. So these are most of the columns are numbers. Just the last one, the composition, is a string. Notice here we've got we're using names as an index. There's two different ways that you can kind of set up Pandas data frames. You can do it like this, where you've got something sort of meaningful as the index column. The index column is kind of treated in a somewhat different way from the other columns, and in here it's just these strings. Another thing you can do is to set it up so that the names would just be an ordinary column, and then the numbers, just the row numbers, would be the index column. So in that case, the index would just be the numbers 0 to 7. But for this example, we've got it with the names as the index column. Okay, so now suppose we want to refer to a single entry in this table. So like this, we can have df.at Earth composition. So that's go. So the first index here is tells us the row. This Earth thing. This refers to the index column. The index column is the names of the planets, and then the second entry here, composition, that refers to the column name. Okay, so these are this list here is the indexes, and this list across here is called the columns. And so the index is Earth, the column is composition, and the value is rock, water, and air. We can also use, so that's df.at. You can also use df.iat. So with the I, it means you're using index numbers instead of these strings here. So this is here we're going in row 2 and column 4, counting from 0 as usual. So row 2 is the row for Earth, and column 4, well, 0 is mass, 1 is diameter, 2 is distance, 3 is period, 4 is temperature. So we're getting here the average temperature on the Earth, 15 degrees centigrade. Yeah. And so you can also do like this, df square bracket diameter, and then a separate square brackets with Mars in. So actually here it's probably maybe we could just click down here. If we just do df diameter, that just gives us this column, and then you put a separate thing in square brackets to say Mars, to say you want the Mars entry in there. But notice that if we do it this way with two pairs of square brackets, and the order is opposite to what it was up here. If we do it with two pairs of square brackets, then we have to give the column first, and then the row. Now we can also do df.lock Mars period. So this actually works out just kind of the same as the df.at. The point about df.lock, we'll see some examples of that later, that with df.lock you can get more than just a single entry. You can get lots of different entries at the same time using df.lock, whereas df.at will only give you one at a time. And for a small data frame, it doesn't really matter which one you use, but if you're doing these kind of absolutely massive data frames that people sometimes use, then there are differences in efficiency. And if you just want a single entry, it's best to use df.at, and then only use df.lock if you actually need it. And again, so there's an ilock as well as the ilock has the same relation to lock as iat has to at. The lock thing, you give the actual names of the row and column, and in the ilock you just give their numbers. Okay, so that's various different ways to get a single entry. On a single row, you do df.lock. So df.lock will work with a row name, whereas just df in itself with square brackets only works with a column name. For here, so here we just so we want a row name. We say df.lock Saturn. We get the whole row of stuff that's about Saturn. And or similarly df.ilock 7, that gives us row number 7, which is all the stuff about Neptune. yeah, notice actually, if we go back here, if we go back here, you see that you've got I've got to use different colours here. There's kind of light green in the body of the table, and then there's blue here for the index, and this red for the column names, and that's how it normally works. It's also the same working here. You've got the index in blue. Right, when we do a row, now the colours kind of change. When we look at a row, then Pandas treats it kind of the same way as a column, and it's got an index. But now these kind of column names here that used to be thought of as column names, now they actually become the index for this series here. So there's in Pandas there's kind of not really a distinction between like row vectors and column vectors. They're sort of the same. Okay. But yeah, so here we get ways to refer to a single column. You can just df square bracket diameter to get the diameter column, or you could df dot temperature is the same as df square bracket temperature. So this is kind of somehow maybe a more familiar type of notation that's used in a bunch of other places in Python, but just with a dot. The thing is though that these column names, they might just be single words like this, but they might have kind of spaces or punctuation or something in the column names. And if there's kind of like spaces or punctuation, then you can't use this notation with a dot. You do have to do the thing with square brackets and quote marks. And then if you want to use df.lock, which again, so the lock and at things, or those are the things that are kind of recommended, especially when you've got extremely large data frames. You need everything to be super efficient. That's so in. So df.lock is recommended over these previous two forms in that case. And here, so if you want to do df.lock to get a single column, you do colon here, which basically means anything in the first slot, and period in the second slot. That gives you so it means any row in the period column. So that gives you this block here. Or you could do df.ilock again. Colon means any row, and then 5 means column 5. So you just get the composition column. If you want several rows, you can do it this instead of it. You can't do it with an at, but you can do it with a lock. So you can do df.ilock 1:5. So that gives you rows from 1 up to 4. As usual, you don't usually include the last index, right? 1:5 means 1 up to just before 5, and df2:6 is the same as with it doesn't matter if I put in the ilock or not, except that the ilock is more efficient. And then, but I could also do df.lock with a colon, and there you go. So this is a little thing slightly exceptional thing here. So if we do this with the labels, then it is inclusive at both ends. So we go from Earth to Jupiter, including Jupiter. Then here's another thing that's kind of a very common sort of usage. You do df temperature greater than 0. So if I just do this thing in the middle, the df temperature greater than 0, that gives me like a sequence of true and false values. It gives you a true value for every planet where the average temperature is positive, and a false value for every planet where the average temperature is negative. But then you put an extra kind of df square brackets around the outside, and that just means it sort of picks out only those rows where you've got a true value. So the overall effect is that when we do this thing here, we just get a smaller data frame, based on the original data frame, but we've thrown away a bunch of the rows. We only keep the rows corresponding to planets where the average temperature is positive, so that just gives us Mercury, Venus, and Earth. And so another thing we could look at for planets where the name starts with an M, so that just gives us Mercury and Mars. But notice, remember here that we can't call this df square bracket name. The name is the index column. The index column is treated differently in a bunch of ways. So in particular, you can't refer to this as df square bracket name. You have to call it df.index because it's the index column. And then you say index starts with M. But also, yeah, I've put in this little dot str in the middle. So that you have to do whenever you want to if you want to treat a column as a column of strings and apply string methods to it, then you have to just put in this extra dot str thing to tell Pandas that you're thinking of the column as being a column of strings. So we do df.index.str, gives us this column regarded as strings, and then the starts with, we need to do that because the starts with method is a method that only applies to strings. And then we do dot starts with m, so that gives us again a sequence of true and false values, true for every row where the planet name starts with an M, and a false for the other ones. And then you put a df square brackets on the outside, so that just gives you a smaller data frame in which you've only kept the rows corresponding to planets that start with M. Yeah, if we want several columns, so here df.lock again with a colon first thing, which means I'm keeping all the rows, but square bracket mass composition, which means I'm going to keep, here if we had this kind of thing here before, we had df.lock colon comma period, which just gives us a single column, but now I want two different columns, so instead of the period there, you've got mass and composition, but inside an extra pair of square brackets. That gives us this data frame like this, where we've got all the rows, but we've only kept the columns for mass and composition. And we could do the same sort of thing here, df.ilock colon comma 1 comma 1 comma 4, so we just keep columns 1 and 4, namely the diameter and temperature. And you can sort of combine these two things to select rows and columns. Okay, so here df.lock from Earth to Mars inclusive, and from mass to period inclusive, so that gives us this little block of stuff that's shown here. Or the same thing with indices. Here we've got rows 4 through 7, and the columns 4 and 5. Yeah. Here's the things that don't work. df square bracket name doesn't work because you have to call it df.index instead. df.at Jupiter doesn't work. The at thing, if we do the df.at with just one, df.at, you always have to give both the row and the column to specify a single entry. df.iat, again here, 1 and 2 colon 3, right? df.iat, that only works, you have to give a specific number for the row, a specific number for the column. You're not allowed to give a range of columns here. And df square bracket earth, that doesn't work. Just doing df with a single index inside that, you have to has to be the thing inside the df has to be like we did up here to give you a single column. You can't refer to a row like that. You have to do df.lock instead if you want to refer to a single row. So that's a bunch of different ways in which we can select parts of our Pandas dataset.